At number 11, we're asked to draw our own Venn diagram and then to use this to determine the validity of the argument. So we're assuming the first two statements are premises, and the third one is the conclusion, and then can we get that conclusion based off the premises? Okay, so let's start with the statement, all horses are green. So we have to kind of think, we get two sets here. We have green things and horse things, and the statement that all horses are green indicate that the horse bubble is inside the green bubble. So let me draw the green bubble. So these would be things that are green, and inside the green bubble we have a horse bubble. Now I don't have to agree with that, but I mean logically, in the real world I know there's not green horses. That's kind of ridiculous, but that's not the point. Okay, so I've got two sets, and one set is inside another set. Then I get to the second premise. Second premise is Trigger is a horse. Well, so I'm going to put Trigger right there somewhere in the horse bubble. So he's clearly inside that. And then can I safely conclude then that Trigger is in fact green? Well, the fact that the Trigger is inside the horse bubble and the horse bubble is inside the green bubble, that actually is a valid argument. Valid argument. Now, just so I can tie this up with things we've seen in class, this would not be considered a sound argument, sound meaning the premises themselves are true on their own individual merits, and yeah, the whole horse being green thing is not true, but it is a valid argument, just not a sound argument, but that's not what the question asks us to do. Number 12, we're asked to illustrate the following statement: 6 times any number is an even number, by stating 4 examples, and then we're asked a question about inductive and deductive. Okay, so let's get to the first part by coming up with examples that fit this particular pattern. So 6 times any number is even. Well, let's just start real simple and say 6 times 1 is 6, and 6 times 2 is 12, and 6 times 3 is 18, and 6 times 4 is 24. Okay. And so now I've got 4 examples that illustrate this statement. Then the second question is it inductive or deductive? Well, inductive is specific to general, so it's an observation of patterns, where deductive is a statement of fact that we take a general statement and look at, say, specific examples of it. Well, in this case, we came up with 4 examples to illustrate this statement. That doesn't mean that my evidence proves it. So this actually is an inductive argument because it's based on observations that I came up with 4 numbers that I multiply 6 by, and it so happens that they're all even. Number 13, give an example that invalidates the following mathematical rule. Okay, so invalidates, we have to understand, means proves false. So it does not work with. I actually like that one better. You can't prove something is necessarily false, but you can cite a counterexample. So we need to come up with 3 numbers that sort of fit this, or that make this pattern be wrong. Now, take a look at the rule and see, do you think to yourself, what is wrong with that? And it's actually an illustration of what's called a distributive property. And it should say AB plus AC, and so that A is missing from the C right there. So all I have to do is just come up with 3 different numbers, and I'm just going to make up 3 numbers, and then I'm just going to show that if I follow this rule, it's actually not true. So if I do 2 times 3 plus 4, and I'm going to put a question mark there because I don't know if it's true that 2 times 3 plus 4 is valid or not until I actually work the math out. So on the left side, order of ops, we have parentheses, so we want to do that first. So that's 2 times 7, and 2 times 7 is 14. And over here, we get 2 times 3, which is 6 plus 4, and 6 plus 4 is 10. So that actually does not, it's not true. Okay, but my example is right there, and it's not just the three numbers that I circled, it's the entire package. It's me actually showing all the steps to show you why it's not true. So it's not good enough just to come up with three numbers, but those are the three numbers that I picked. And actually, there's an infinite number of numbers that would satisfy that. So, all right, number 14, we are given a statement and we're asked to identify the conclusion of this. So again, I'm going to caution you as we read this, think to yourself, what am I supposed to walk away thinking? There's going to be a premise or evidence for something, and then I have to figure out what that something is. Okay? So the statement reads, the stores at the mall should stay open later this month. After all, it is the holiday season and there are more shoppers. Okay, so a lot of things to pick from here. To me, I get the fact that that first sentence is what I should be focusing my attention on. The holiday season and the more shoppers part is evidence as to why the mall should actually stay open. So that would be the conclusion then. So the conclusion is the stores at the mall should stay open later this month. Number 15, a dictator of a foreign country enacted a ban on all firearms, citing accidental deaths among children as his main concern. Identify other issues that might be involved in his decision to ban firearms. Okay. All right, so this is sort of a, wouldn't say common sense, but you have to think about a bigger picture here. This dictator, through the goodness of his heart, has decided we're going to ban firearms because children hurt themselves. Can you think of another reason why he might want to ban firearms? And the big one that I can think of is he's a dictator. No firearms means no rebellion. Now, that's one possible issue that he might be using, but in my mind, when I see dictator of a foreign country, that's what I'm thinking. If he's got control over the firearms, then he's also exhibiting some sort of control over citizenry. But again, there's lots of other possible things that you could say here that would be worth giving full credit on. Number 16, swimming is healthy because it improves your cardiovascular system. Identify any hidden assumptions in this argument. So again, you want to think for a second, well, in order for that statement to be true, what am I assuming also has to be true? Okay, so one thing that sort of jumps out at me is sort of the wording that they choose to use. They're saying swimming is healthy and here is the evidence. Well, the evidence, and I don't think anyone will argue against this, but the evidence is, we're assuming, is connected to the predicate of the sentence. In other words, we're assuming that improving your cardiovascular system actually does make someone healthy. Now, I'm not arguing against that, but that would be sort of the big assumption we're making, is that this cardiovascular system, and we might not know what that is, but we're, in the sentence, it's suggesting that that system happens to improve health. So big assumption would be improving cardiovascular system is healthy. Okay, so in 17, we're given some information about a trip, and then we need to describe some options and then talk about what the best decision is for us. So let's see. So let's read it. Planning a trip to Greece 9 months in advance, you find an airline that offers two options. Plan A, you buy a fully refundable ticket for $2,100, and Plan B, you buy a $1,600 ticket, but you forfeit $250 if the ticket is changed or canceled. Okay, so I'm going to pull up a calculator, and I'm going to use Excel because I happen to think that is a perfectly good calculator. And I'm just going to outline the options here and then what the cost is. So we're going to say go or don't go. What would it cost us? So if I go for plan A, it's $2,100. If I don't go, it's 0. It's fully refundable. Plan B is going to cost me $1,600. And if I don't go, it's going to cost me $250. Okay, so let's talk about sort of what the consequences of certain decisions are. So if I subtract the two numbers, now if you're not familiar with Excel, let me kind of give you a little bit of heads up on this. So I'm going to click on a cell and I'm going to type equals, and then I'm going to use my mouse and actually click on the numbers rather than type them in. And it'll do the calculations for me. And the nice part is that if later on I want to change something, I can. Now for this example, we're not going to, but okay, so if I go with plan A, it's going to cost me $500. Plan A is $500 more expensive. Let's see, plan A is 500 more. Now, if I don't go, plan B is $250 more expensive. Okay, so as far as me making a decision goes, I kind of have to weigh the likelihood of me canceling. But most likely, if I forked out $2,000 to go to Greece, I plan on going. So the cheaper option would be the $1,600, and it only gets more expensive if I don't go. But on the same note, if I didn't go, I've probably got other things to worry about. So $250 is not going to be a big deal. So as far as which would I buy, I would buy Plan B. All right, so Plan B is $500. Oops, $500 cheaper than Plan A. It would be less expensive to go with Plan B. All right, number 18, state whether you expect the distribution of shoe sizes in a sample of 100 men to be symmetric, left skewed, right skewed, and explain. So we have to kind of remind ourselves of what these words mean. Symmetric is a nice bell-shaped curve where I expect to be a bunch of numbers to be in the middle of the graph and very few numbers to be on the extremes or ends of the graph. Left skewed means most of the data is on the right side and there's a gap on the left. Right skewed is sort of the reverse logic. And I think, let me pull up a picture of these guys. Okay, so I just did a Google search and found this. So this picture in the middle is what we would consider to be symmetrical. And here you can see there's a lack of data on the right, so this would be right skewed. And there's a lack of data on the left, so this would be left skewed. Okay, so let's go back to our actual question. Question is, we're looking at 100 guys. What do we expect to see with shoe sizes? Most guys are about 5'10", 5'11", 12 foot, 6 foot. So there's an expectation that most guys are about the same height, and very few really tall guys are out there, and very few really short guys are out there. So I would expect this to be symmetric because shoe sizes are like heights, and most guys are around the same height. Number 19, find the mean of the following data. Okay, so I'm going to go back to my Excel friend, and I'm going to open up a new sheet. And the first thing I'm going to do is I'm going to type in all those numbers. So let me do that real quick. So in your case, you might, oops, if I type it incorrectly, shouldn't it? Again, I'm an Excel fan. I think the whole class can be done in Excel, honestly. And you're more than welcome to figure out another piece of technology if you want, or just go with Excel. Okay. Now that I've done that, I can tell Excel to add up all of these numbers. So I'm going to show you a couple of different ways to do this question. So sum all of this, and then I can tell it to divide by the total. So we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So divide by 10, and I get 73.3. There's actually one more function in Excel called average that if I click on all the numbers, it will actually do the same calculation for me. So 73.3 is the answer. By the way, if you do choose to use Excel to work out these questions, again, which I highly recommend, then to cover yourself, what I would suggest you do is save the Excel file and email it to me as part of your scratch work for the test. And that will actually be fine, as long as I can go back and see what you were thinking when you worked it out. All right, number 20, find the median of this set of numbers. And again, let me pull up our Excel friend here. And I am going to input these numbers, and again, you might have a calculator or some other device to do that on. 39, 52, and 42. Now, a couple of nice things about Excel. I can highlight a bunch of numbers and then kind of show you how this works here. I'm going to go to data, and I'm going to have it sort it from A to Z. Now, if I go, let me show you Z to A versus A to Z. A to Z says start with the lowest, go to the highest. Z to A says start with the highest, go to the lowest. So that's nice. That's nice that it does that. Okay. And then from here, I'm going to kind of do this. Where to find the median, I want to go for the middlemost number. So I'm going to go from the top end and the bottom end and just start eliminating pairs. Now here I notice I get two numbers in the middle. So to find the median, what I want to do is I want to add those numbers up and divide by 2 in the, if there's an an even set of numbers in the middle. And obviously that divided by 2 is 14. So that would be the median of our numbers. And there actually is a median function in Excel. And so I can just type the word median in, and it will also generate that number for me. So the median for this data set is 14.